Our next unit of study is going to be congruent triangles, and we're going to begin this by looking more generally at congruent figures. So, by way of definition, congruent figures are those that are shapes that have the exact same size and shape. Now, they might be rotated from one another, reflections or translations, movements around in the field, but they have the same shape. When we look at congruent polygons, we're looking at those that have the same congruent corresponding parts. And we name congruent figures, or congruent polygons, in order by congruence of their corners or their vertices. So in the shape here that you see, we can take a quick look and see that angle A would be the same as angle E. B is the same as F. C is the same as G. And D is the same as H. So when I go to name these, I will do it in a manner that reflects that. I will simply say that quadrilateral A, B, C, D is congruent to quadrilateral E, F, G, and H. It would be improper for me to say that ABCD is congruent to HGFE, because that would imply that angle A and angle H are congruent to one another, which they are not. So the order is very important. With this, I can take my vertices in pairs and say that line segment AB is congruent to line segment EF because they're simply listed in that order. So BC would be congruent to FG, CD congruent to GH, and DA would be congruent to HE simply by looking at their locations in the ordering and listing of the congruence. So being able to name our shapes and name them by corresponding parts becomes very important. And we can use this as we move forward in talking about correspondence to determine whether or not objects are congruent to one another, and if so, how to name them. So let's take a look at that. So here we're given a shape, and we need to determine if the triangles that are formed by it are congruent to one another. And we can do this by begin listing out parts. We can say that AB, line segment AB, is congruent to line segment ED. And that's a given. There's one hash mark for each one, so we can justify that. We can say that BC is equal to DC because BC, or we can say that line segment BC is congruent to line segment DC because BC equals 4 and 4 is equal to DC. Similarly, we can say that line segment AC is congruent to line segment EC because AC is equal to 6, which is equal to EC. Angle B is congruent to angle D. And since AB and DE are parallel lines, those are alternate interior angles, but this is just a given fact. We can also say that angle A is congruent to angle E, and that also was a given, or we could justify it by our alternate interior angles again. Then angle BCA is congruent to angle DCE because they are vertical angles, and vertical angles are congruent to one another. So we have 3 sets of congruent sides and 3 sets of congruent angles. So by this, we'd be able to ascertain or justify that these two triangles are congruent. Now it comes down to how to name them. We need to name them in order. So if I start out by saying triangle ABC, I need to list out the vertices in the same order of correspondence. So what angle is congruent to angle A? And that is angle E. What is congruent to angle B up here? Well, that was angle D. And then what was congruent to angle C? And that again is going to be angle C because those vertical angles. So we're able to identify the fact that these are congruent and list out their congruence in a proper order when it comes to triangles. So with this, and beginning our look at congruence and congruent triangles, we are going to be introduced to our first theorem in this unit, and that is theorem 4. Now theorem 4.1 is the third angles theorem, and it states if two angles of one triangle are congruent to two angles of another triangle, then the third triangles are congruent. And the justification of this comes in the fact of the angle sum theorem, because if two angles in one triangle add up to, say, x degrees, then the third angle is 180 minus x. So if both pairs of two angles in two different triangles add up to x, then both of the remaining ones would be 180 minus whatever that x value is. So from this, can we conclude anything about the two triangles that are shown in the kite in this diagram, kite EFGH? So let's start looking at pieces, and let's do this in a proof format. So we have angle E is congruent to angle G, and that's a given. Angle EFH is going to be congruent to angle GFH, and that again is a given fact in our diagram. We have EF is congruent to GF, given. And we have EH is congruent to GH. And again, that's a given. Now we're going to have to start looking for our last two. We need two more angles to be congruent, and we need two more line segments. Well, the two more angles can be congruent. We can say that angle FHE is congruent to angle FHG by third angles theorem. Now we need that last side. Well, FH is congruent to FH, and the justification for that is the reflexive property of congruence. A line segment or angle will always be congruent to itself. So we have, again, three congruent sides and three congruent angles, so we can justify that yes, these two triangles are congruent to one another. So as we go through, triangle EFH will be congruent to triangle GFH. Again, putting those in order from their corresponding angles. So this begins our look into congruent triangles by looking at congruent figures, and will become a basis for how we're going to do things. And be sure that you have these ideas down, the theorems in a good list and location for quick reference, and be ready to use them as we move forward into the other parts of this unit.